Hey everybody, this is Larry. This is day 28 of the September Leetcode Daily Challenge. So only 3 more days to go including this one. So excited. I'm still in Portugal in the city of Portimao. Portimao. Yeah, I don't know what else to say about it. I just woke up a little bit tired. It's 8 a.m. So yeah. Okay, today's problem is sort away by parity. 2. So if, yeah, I usually sub these live, so if it's a little bit slow, just watch it on the fastest speed or something like that. Okay, so today's problem is, let's see, half of the integers are odd, the other is even, sort the way so that num I is odd, and then when num I is even, I is even. What does that mean again? When num sub I is odd, okay, so half of the numbers, is it even? Okay, so n is even um, when num sub I is odd, whenever num sub even is even. Okay. So basically, you want to put the even numbers in the parity and all the odd numbers in. Okay. Um, very weird way of putting it, but excuse me. Yeah. So n is 2 times 10 to the fourth. So any n squared type algorithm is going to be too slow. But yeah. Whenever num sub I is even, I is even. Yeah, this is sorry. I'm just having this understanding issue right now, but that's okay. Half of the integers is number even, okay. Um, mm, a couple of things you can do. The first thing you can notice is that num sub I is less than 1,000, so you can do a sort of a bucket sort, or yeah, you can do a sort of a bucket sort, but of course that's going to be linear space, especially in this case because um, yeah. You can also do what was it called? Get all the name of these sort anymore. But the one where you take the last bit, and of course that the odd and evens, that's going to be a thing. Uh, yeah. You can also do it in place, which is what they ask you, of course, um, by just keeping track of um, like an like having like a maybe somewhere my guess is some variation of the 2 pointers algorithm, but instead of 2 pointers, maybe have 4 pointers or something like that. Maybe three. I don't even know really or four, but something to kind of keep track of. Okay, the progress that we need to make, and then just like keeping track of the next number that we need to add and the number that we're processing, right? So, for example, here that this is even. Now here the next odd we know it's going to be on here, and because you have 3 pointers and you go through it 3 times the array or something like that, it's going to be linear time. So that's my guess, and of course this is yeah. I mean, what is that? It's not bucket sort. What is the? I can't remember the name right now. I'm just waking up. Is it a little awkward? Let's see. This is bothering me. So yeah, it's one of the radix sort. Yeah, so you can do a radix sort on the last bit, but of course, um, yeah, you have to keep track of the original things. So, but the same idea applies. It's just different places. Yeah, and and because you only sort by one bit of information, I think linear time is a okay lower bound. So and also we're not doing comparison based sort anyway. So n log n lower bound doesn't apply in case you're wondering why we can do it. Wow, maybe I should have just slept a little bit more first. Sorry, friends, if the quality is a little bit lacking today. Yeah, I just didn't sleep enough. But okay, so let's mm, yeah, let's get started. Yeah, and the thing with a swap in this case is that every swap always swaps two numbers into place, right? Meaning that the two numbers are out of place and you swap, so then that means that, yeah, because it wouldn't make sense to swap an odd with an odd and an even with an even. So in that case, you have this kind of, yeah, at most you can have n over 2 swaps for that reason. So I think it should be okay. And all the constraints I make it so that you're forced anyway. Okay. I think I talked enough about this problem, so let's actually implement some stuff. I think that should be okay, but that implementation may be a little bit weird, but we'll have to think about it. But yeah, something like this maybe. So yeah, so okay. Well, we can just do growth time in nums. Okay, if x is even, then we want to get an even number. So yeah, so then we go from left to right. I want to just mess up sometimes at the very end. I should be okay, but maybe I'm wrong. Wow. Sorry, I forgot about how to do this again. Or the question. Num sub I is odd. I is odd. Okay, so so this maybe I'm thinking about it a little bit too funkily. Yeah, okay. I'm not looking at this number. I'm looking at current. Oops. So okay. So while the index is even, the number has to be even. Okay, so that's fine. So while this is equal to 2, even and now basically, okay, we have a current index and we're looking at the even index to do this. So yeah, okay. So otherwise we do num. Yeah, that's why I didn't want to do enumerate, I think. Because I think this actually, because we're modifying the sequence, so that's why this is a little bit wonky. Okay, fine. So while the index is even, or if the index is even, we look at the even index, we increment, okay, and then else we do the same with odd number. Oops, my alarm clock. I wonder if this will. I feel like there's an invariant that makes this so that it doesn't go out of bounds, but maybe I'm wrong on that one. So we'll see. Do I have to return? I guess so. I mean, this is in place, so returning makes kind of weird sense, but okay. Yeah, I mean, I guess this looks okay, so maybe this is the last one. If this is okay, this is okay. I mean, at least I'm happy about it. Maybe I'm still wrong though, but I feel like at least I'm happy enough to submit. Let's go. Cool. Yeah, so it's good that my intuition was good. Though to be honest, I feel like I'm a little bit I mean, you could see it and maybe feel it. Still a little bit sleepy, so this was a little bit trickier for me to explain. But yeah, but basically, this is just because everything is forced, and therefore, you can see. Look, so in terms of complexity, you look at each of these three indexes, um, and each of these goes from 0 to n, and they are like independent of each other, right? So that means that each numbers and numbers array will only happen 3 times, one for each index. So it's O of 1 for each number, so it's going to be linear time. In terms of space, we did it in place, right? So is O of 1 space, if you want to call it that extra space. Um, as you know, usually I actually do complain about in place problems because it doesn't usually make sense to have a function that's in place, and it's just like, I don't know, it's there for a weird reason, and you're like modifying the input as a funky thing to save some space that may not really make sense. That said, for this problem, I think it kind of makes sense because to have it in place, because sorting an array by parity, like, I mean, I'm not saying that this is a common function per se, but if you have a function like this, you can imagine the API design being that requiring it in place because to keep the space in a consistent location, right? Because when you sort, very often you want to change the element of the the contents of the array. So I think for this one, it makes sense to have it in place. And so yeah, um, that's all I have for this one. I think, to be honest, I'm probably a little bit sketchy about this video, as I said. Like, I'm a little bit sleepy still, to be honest. But also, yeah, but you can kind of also see the depth of maybe experience that you know. Like, I came up with this without really all the proofs, but mostly probably because I've done enough of these problems before. So hopefully, I don't know. That's just, and I'm not saying that to brag or anything per se, but just sometimes that's how it comes up, right? So um, yeah. Anyway, that's all I have for today. I'm probably gonna go back to take a nap. So I'll see you later. Stay good, stay healthy, to good mental health. Let's finish the rest of the month. I'll see you later. Bye bye.